Hello everyone. Nice to meet you. My name is Myo Mong Mong. I am a lecturer. I work for Chemistry Department of Digam University. Now, I teach you the lesson of Physical Chemistry, Chem 4108, 4208, for 4th year and 2nd year honors chemistry students. Before the lesson, I talk you about the contents you studied. There are 3 chapters in prescribed textbook. So, you have to study about electrolytes in solution in chapter 1. The second is electromotive force of electrochemical cells. And chapter 3 quantum chemistry. Firstly, you should know conductor. Conductor is a substance which allow electric current to pass through it. And also, you have to know that there are 2 types of conductors, metallic and electrolytic conductors. But they have different facts as well. Difference between metallic and electrolytic conductors are that metallic conductor, the electricity is conducted by the flow of electrons from negative potential to a positive, less negative, potential. No new chemical products are formed by conducting electricity. The conductance decreases with the increase of temperature in metallic conductor. Electrolytic conductor. The electric current is carried by the charged ions moving towards the oppositely charged electrodes. The evolution of some gases or deposition of some metals is formed by the definite chemical process. The conductance increases with the rise of temperature in electrolytic conductor. Let's move to definitions and mathematical expressions. Ohm's law. Ohm's law states that the electric current flowing through a conductor of the cell is proportional to the potential difference across the cell. In mathematical expression, I equals V by R, where I equals electrical current, ampere, V equals electrical potential, volt, R equals electrical resistance, ohm or volt per ampere. And the second you should study resistance. The resistance, R, of a conductor is proportional directly to the length between the electrodes and inversely to the area of its cross-section. R equals ρ into L by A, where R equals electrical resistance, ohm, L equals length, meter, A equals cross-sectional area, square meter, ρ equals resistivity or specific resistance, ohm meter. Conductance, or conductivity. The power of substance to conduct electricity and the reciprocal of the electrical resistance is called conductance or conductivity, L. In mathematical expression, L equals 1 by R, where L equals conductance or conductivity, Siemens or per ohm. Here, I suggest that you should use the unit of conductance in per ohm instead of Siemens. Next, specific conductance, or specific conductivity. The reciprocal of resistivity is known as the specific conductance. In expression, kappa equals 1 by ρ. The unit of kappa is Siemens per meter or per ohm per meter. Here, we have to use the unit per ohm per meter. Next, cell constant. The ratio of the length between 2 electrodes to its cross-section area is the cell constant of a metallic conductor. So, cell constant equals L by A, where L equals length of conductance, meter, A equals its cross-sectional area, square meter. Here, the SI unit of cell constant is per meter. Then, I discuss you the relationship between cell constant and conductance or specific conductance. The resistance R equals ρ into L by A. Since ρ equals 1 by kappa, then R equals 1 by kappa into L by A. Since cell constant equals L by A, then cell constant equals kappa into R. Since R equals 1 by L, then cell constant equals kappa by L. Hence, cell constant has 3 mathematical equations. Cell constant equals L by A, cell constant equals kappa into R, and cell constant equals kappa by L. So, shall we compute example 1.1? The problem is that a conductivity cell has a resistance of 747.5 ohm, when it is filled with 0.010 molarity KCl solution, and a resistance of 876 ohm when it is filled with an 0.005 molarity CaCl2 solution. Both measurements are at 25 degrees Celsius. Calculate the specific conductance of the CaCl2 solution. Given that kappa of 0.14114 per ohm per meter of KCl solution at 25 degrees Celsius. In problem, we are given that two different solutions are KCl and next, CaCl2 solution. So, in cell of KCl solution, R equals 747.5 ohm, kappa equals 0.14114 per ohm per meter. These two given parameters have a relationship. That is, cell constant equals kappa into R. When their respective values are substituted, then cell constant is obtained by 105.502 per meter. We can apply to calculate the required parameter of CaCl2 solution by using cell constant's value. In cell of CaCl2 solution, we are given that R equals 876 ohm. So, in cell constant equals kappa into R. If we have substituted the values 105.502 per meter in cell constant and R value 876 ohm respectively, then, we will obtain kappa 0.12044 per ohm per meter. Now, you should try exercise 1. The specific conductance of a 0.1 molarity KCl aqueous solution at 25 degrees Celsius is 1.289 per ohm per meter. What are the values of the conductance and resistance of a conductance cell for which the electrodes have an effective area of 2.037 square centimeter? And are separated by a distance of 0.531 centimeter? You are given hint. Try it out. I will have taught you molar conductance, or molar conductivity. As symbol it is called lambda molar C. Lambda molar C equals kappa by C. Where, as you have known, kappa equals specific conductance, per ohm per meter. C equals molar concentration, mole per liter. The SI units of lambda molar C is per ohm square meter per mole. Here, I ask a question that, why is the factor 10 power minus 3 cubic meter per liter required to multiply its mathematical expression for SI units? As definition, lambda molar C equals kappa by C. So, units of lambda molar C equals per ohm per meter divided by mole per liter. We rearrange that the units of lambda molar C equals per ohm per meter per mole and liter multiplied by 1. Since 1 liter equals 10 power minus 3 cubic meter, and 1 equals 10 power minus 3 cubic meter per liter, we can substitute in 1. So, units of lambda molar C equals per ohm per meter per mole liter a whole into 10 power minus 3 cubic meter per liter. So, the mathematical expression of molar conductivity is lambda molar C equals kappa by C into 10 power minus 3 cubic meter per liter. Hence, the factor of 10 power minus 3 cubic meter per liter is required to multiply its mathematical expression for SI units. Next, shall we compute example 1.2? The problem is that, calculate the molar conductance of 0.005 molarity aqueous CaCl2 from the conductance of 0.1204 per ohm per meter. In problem, we are given that C equals 0.005 molarity also equals 0.005 mole per liter. Specific conductivity kappa equals 0.1204 per ohm per meter. It is also called molar conductance. Lambda molar C equals kappa by C into 10 power minus 3 cubic meter per liter. We can substitute the values of kappa and C respectively. Finally, we can calculate the value of lambda molar C. Lambda molar C equals 0.02410 per ohm square meter per mole. Next, shall we compute exercise 3 together? The problem is that the resistance of a cell is 192.3 ohm when it is filled with 0.1 molarity KCl. its resistance is 6363 ohm when it is filled with 0.003186 molarity NaCl solution. Both measurements are at 25 degrees Celsius. What are the specific conductance of the solution? And the molar conductance of NaCl in solution? Given that kappa of 0.1 molarity KCl solution at 25 degrees Celsius equals 1.2886 per ohm per meter. In problem, we are given that two different solutions are KCl and NaCl solution. So, in cell of KCl solution, kappa equals 1.2886 per ohm per meter is given at the end of question. R equals 192.3 ohm. These two given parameters have a relationship. That is, cell constant equals kappa into R. When their respective values are substituted, then cell constant is obtained by 247.798 per meter. We can use cell constant's value in cell of CaCl2 solution. We are given that R equals 6363 ohm. So, cell constant equals kappa into R. If we have substituted the values 247.798 per meter in cell constant and R value 6363 ohm respectively, we will obtain the value kappa equals 0.039 per ohm per meter. Then, the concentration C equals 0.003186 mole per liter is given. So, the values of kappa and C are substituted in lambda molar C expression. Finally, we will obtain that lambda molar C equals 0.012 per ohm square meter per mole. Finally, I encourage you. You must learn everything at everywhere. And you share again. Thank for your time. I will be back. See you later.